The American allies saw the value of this team approach, and soon its military included what were called operations analysis groups. They were comprised of mathematicians, statisticians, physicists, and others. After the war, ORMS became recognized as a scientific discipline, and it began to find its way into scores of businesses, nonprofit, and government organizations. With the eventual arrival of computers, ORMS really took hold. Soon there dawned a whole new era in business.
This is UNIVAC, tomorrow's miracle of electronics, here today. In government, industry, science, and in the defense of our nation.
Well, as you've probably guessed by now, ORMS has its roots in mathematics. Mathematics designed to help people make decisions in the real world. The key is to have an approach that works in an environment that's often changing. And since it's often impractical or expensive to test a proposed solution in an actual situation, you need something that represents the essence of the problem. You need, in other words, an efficient and reliable model. Now, there are many types of ORMS applications in the business world. For example, retail companies use it to assign territories to its salespeople to determine the number of accounts they'll serve and establish travel routes to minimize the distances they cover. Now, in each of these instances, the point is to find ways to increase productivity while minimizing the costs. The end result, of course, being maximizing profits. Another common application is one having to do with resource distribution. Well, this was the logistical problem the Yellow Freight Delivery Company faced in finding the best way to manage its freight routing. It's a problem many transportation and shipping companies have in a business where things are constantly on the move. Key decision makers, in this case Yellow Freight's terminal managers, lacked the information they needed to coordinate the activities of trucks, drivers, and terminals around the network. The result led to inefficiencies that severely affected their business. Now, Yellow Freight's goal was to balance the many variables that affect the efficient operation of their system and then ultimately lower their costs. So the company asked Princeton professor Warren Powell to study the problem.
We found the problem was hopelessly large. The breakthrough was realizing that the mathematics of dynamic programming. Dynamic programming is the programming of activities over time, which is the word dynamic. The mathematics of dynamic programming allowed us to take the problem and break it down into smaller problems in individual time slices.
Well, Professor Powell came up with a model which replicated the way the Yellow Freight network really operated and the way decisions had been made by getting high-powered computers to do what people in the field had been doing. The result was an interactive core planning system program called SysMol.
SysMol is the core planning system at Yellow Freight that allows them to see problems as they're happening, plan the flows of drivers, manage the empties, prioritize the loads, anticipate problems before they can happen.
For Yellow Freight, operations research allows it to take advantage of the information it has in a competitive business environment and use it with a higher level of precision and efficiency. But that's not all. Powell soon realized that Yellow Freight's problem was not unique. He found that, whether it's automobiles, aircraft, products, or employees, this tool allows you to look into the future, anticipate needs, and then make the best decisions. Solving problems having to do with managing resources is one thing, but businesses face many others too, like the growth problems the San Miguel Corporation faced as it grew from a one-product, family-run company to a large multinational agribusiness. In fact, like at Disney, San Miguel relies on operations research. Its OR department has a hand in planning, whether it's determining the location of a new plant or warehouse, or setting up production schedules in a factory. Rather than risking the cost of experimenting in real-life situations, the operations research experts devise mathematical models which can be studied for their effectiveness. As a consequence, before any real change occurs, the company can review the impact of any number of proposed ideas. In fact, San Miguel's commitment to operations research has won it international recognition. Clearly, as many businesses have found, a good model can save time and money. Helping companies run efficiently has its rewards, but OR is not all business. There's also a little bit of treasure hunting involved, too. Actually, the story begins in 1857 with a ship called the Central America.
When people wanted to come from California back to New York City, you didn't go across the country. There was no transcontinental railroad. So if you had the money, you would take a steamship from San Francisco down to the west coast of Panama, and there was a nice train that would meet you, and that would take you across Panama to the east coast, and waiting for you on the east coast would be another U.S. mail steamer, in this case the SS Central America. Now in those days they didn't have a weather service, they didn't have telegraph, at least to the ship, so they didn't know that they were steaming into a hurricane. When they started to meet the rough weather, they were sort of were of the mindset that sail-powered ships kind of had to give way to the weather. But, you know, by God, this was steam-powered. This didn't have to give way to the elements. They were just going to plow through this storm. And that turned out, in effect, to be their undoing, because the ship sprung a leak in the forward part of the ship, and they could not keep the water level out of the ship, even with people bailing by hand. And eventually the water level came up over the coal, so that they couldn't keep the steam engines going in the ship anymore, and finally they just were adrift at the mercy of the weather. When they saw a ship of the Marine about noon, the Marine took off all the women and children, but the seas got too rough for them to continue doing that. They had to give that up about 6:30 or so at night. And about 8:30, the ship finally went down, fired its rockets. They could see the rockets from the brig Marine, which was standing close by. And Captain Herndon went down at the wheel of the ship in his full military uniform, and that's the last that was ever seen of him.
At the time, it was the greatest sea disaster in American history, with 425 people losing their lives. In addition to the deaths, an estimated $400 million of gold bars and coins from the San Francisco Mint sank to the ocean bottom over 1.5 miles below. And for nearly 130 years, that's where the gold stayed. Because of the storm's strength and the depth of the ocean, the exact location where the Central America went down remained a mystery.
The operational problem is how to find this wreck on the ocean bottom. The mathematical problem is to take the information that's available to us and to properly represent what that information tells us about the location of the wreck. And properly representing that means taking account of all the uncertainties in the information.
Dr. Stone used a strategy based on an operations research method called search theory. But even with search theory, finding the Central America wasn't going to be a snap. There was, after all, over 1,000 square miles of ocean to search, an area about the size of the state of Rhode Island. And using the information they had, much of which was conflicting, Dr. Stone and his team spent months creating what's called a probability map of the ocean floor.
Once you've got that probability map, the second part is to lay out a plan, a search plan that gives you a high probability of success.
After spending more than 3 summers searching the ocean floor, the search team found the ship.
Here we go. Oh, you know what that is. Yeah, I'm winching up right now.
And with it, the gold. Today, search theory is still very much in use, whether it's finding wrecked ships or planes downed in the ocean, or even its original purpose, tracking submarines. But one thing's for sure. Without the systematic planning that went into the probability maps, the search for the Central America might still be going on.